Okay, today we are going to learn a very important topic. It's called the loan amortization. Uh, the goal of this lecture is to study how one can pay back a loan through equal payments, meaning through a level annuity. So basically what we are trying to do today is to, um, let's say, goal today is to study how a loan can be paid back through level annuity. Okay, uh, the frequency, well, does not need to be at yearly level, so it can be piecely or maybe piecely. So in real life, pretty much all the typical loans are paid on a monthly basis. Let's say if you have a mortgage, if you have a car loan, you will need to pay on a monthly basis. So here, P would be 12. Uh, it's possible to have a non-level annuity. Let's say you might hear some floating mortgage, meaning the rate, the interest rate is actually floating. So in that sense, the payment obviously is varying, but the conventional. So that's why for the conventional. So basically here, what we focus on example would be conventional mortgage. Okay, when you say conventional, that would be first of all, it's always fixed term. Either in the US, the typical case would be either 15 or 30 years, fixed. Right, so fixed interest rate. Once the interest rate is fixed, the payment would be fixed. That's something we're trying to study. Let's begin with basic setup. What we want. Okay, let's say the loan amount. The loan amount is L. Obviously, L stands for loan. It is the present value, right? So that is the present value of the loan at time 0. So basically, that's how much you borrow, right? And the term is N. I do not exactly specify the unit. In most cases, it would be years. Term means the number of payments. Not exactly the number. So let me erase this. We will do it question by question. In a standard setup, N would be the number of years, and you pay it on an annual basis. Sometimes N can be, let's say, 15 years, but you may pay it more frequently than once a year, right? Like 12 times a year. Then it would be 12 times N would be the number of payments. So here, let's just call it term. And the corresponding interest rate is I. So again, technically, I should be more careful on saying what I is. And first of all, it is the effective interest rate. And then this interest rate corresponds exactly to the time interval you choose. So let's say suppose the default case is that one pays on an annual basis, and then I would be the annual effective interest rate. Okay, but of course we can also study monthly if you want. So let the equal installment or the equal payment be denoted by X. Okay, so the first thing is we are trying to use an annuity to pay back the loan, this particular loan. Of course, that means, well, mathematically, it's very easy. Right, so that is the mathematical equation behind behind all the mortgage setup, right? It's actually not complicated, right? So we are trying to use an annuity to pay back a specific loan with amount L. That means the present value of this annuity is supposed to be equal to the loan amount, right? So that's the equation. From this equation, we easily see that the equal payment would be given by this equation, right? L is given, right? That's the exact amount you are trying to borrow. The denominator is the present value of a standard annuity immediate, right? Again, the default setup is the payment. All the payments are made by the end of each year, each month, etc. Right? So that's why it's a standard annuity immediate. We have A. If you want to recall the formula we have, this would be 1 minus 1 plus I to negative n divided by I. So this is the formula. Okay. And once we apply this, we easily get the result. Let's look at the example. So a bank makes a loan of $5,000. So L is 5,000. Level payments are made annually. Annually in areas. That is the end of each year for 5 years. For 5 years. Okay, so let's say n is 5. The banks use the annual effective interest rate of 6%. Okay, calculate the amount of each payment using the amortization. By the way, this is amortization. Amortization method is to use an annuity to pay back a loan. Okay, so we easily get the result. So L divided by A here is 5 at 6%. So you can easily calculate is 5,000. This, well, you don't even need to know the formula because your financial calculator can get you the result. It's about 4.212364. So you get the level payments, which is 1,186.98 cents. Okay, that's how you solve this equation, this question. But of course, what we may want to know more is what would be the balance after a specific number of years, right? What would be the interest I paid in a specific year? So what we want to know more is what would be the balance. Let's use BT to denote. Okay, BT is the outstanding amount, meaning this is the amount you still own at T. Okay, that means after the payment at T. At time T, and let's call this to be IT. This is the amount of interest. Amount of interest paid over the T's period. So in our example is a year, in example 5.15. So those are the notation, okay? What do we want? Example 5.15. We want to know the amount of loan outstanding immediately after the second loan payment. So we want to know B2. Okay. Well, obviously, right, this is obvious, right? The very first B0 is equal to L, that is $5,000. Okay, and then in the first year we pay 1,000, a little over 1,000. Okay, close to $1,200. Not all of them is paid to the principal, right? You need to pay the interest. So that is the key of amortization method. In each payment, so let me type it down. under the amortization method, each payment X is divided into two parts. One part pays the interest and the other contributes to the outstanding principal. So that means at the very beginning, the portion of interest is probably very big because you have a big outstanding balance. And how do you calculate IT? IT is the interest, right? That means it will be the previous outstanding times the interest. This is how you calculate the interest. For instance, what would be the first interest payment? It would be I times B0, right? So I is, what is I? I is 6%. Your original amount is 5,000. So the first interest is $300, and our payment is always the same, right? So let's use something to call PT. Okay, so PT is the difference. So one pays the interest, so let's call this IT. The other contributes to PT. Okay, and because the payments always equal, so this is the same no matter what time you have. Okay, so P1 would be X minus I1. So our X is 1,100. What is the number? 86 minus 300. This gives you 886.8. Okay. Once you have done this, we recalculate. What would be my new balance? Okay. My new balance would be the previous one, which is B0, minus how much is paid in this year, right? In this year, I paid exactly this amount. 300 goes to interest. The remaining 800 something goes to the principal. So you need to get a calculator to do this. 5,000 minus 886.98. It's about 4,113.03. Okay, this is we finished for year one. Now let's move on to year two. So my first thing to calculate is the new interest, which would be my previous balance times the interest rate. So continue times by 0.06. The amount of interest now is $246.78. Well, it's a little bit more than that. Once I know the interest payment in the second year, I immediately know how much of my payment will be used to repay the outstanding principal, right? The payment is always the same, but now since I paid less towards interest in the second year, I will have more money to be paid towards the principal. It's actually more than 900 now. Okay, and then I calculate the outstanding balance, which is the previous one minus how much I paid towards principal in the second year. Okay, minus this 4113.02. So I will have my new balance, which is 3,172.8212, and it goes on. Okay. Of course, for a specific question, we don't always want to repeat this, right? We want something more systemic to help us to do this, okay? So now we analyze. We have actually two methods to handle this. The first method is what people call prospective. method. Okay, the idea is very simple. We want to know time t, so it ends at time n. Since it's already after the payment at time t, so there's nothing at time t now, the next payment will be at t plus 1 x. Right? So in order to figure out the remaining balance, right, bt is nothing but how many payments you still need to pay, right? In this case, it will be n minus t, right? So that's the remaining payments we still need to pay. So that's exactly why we call it prospective, because we look into future. We look into future to see how many more payments we will need to pay, right? That's looking into the future. That's why it's called prospective method, right? So whatever the outstanding balance at this time would be the present value. So this is the present value of all future remaining payments. So that's why this method is called prospective. You look into future to see how many more payments you still need to make, and then the present value would be equal to the current outstanding or the current balance, right? So using this, we easily calculate B2 would be X times, well, A5 minus 2. I have 3 more payments left, right? So this will easily get me the result, right? So it's the same. So if you round to 2 decimal places, it's 82. We did a little bit more previously. So that's one method. Okay. The second one, it takes a little effort to understand. Is the opposite side. It's called retrospective method. Okay. What we do is 1, 2, all the way to t. Of course, it will continue. Okay. So what we do is we look at what has already been done. Okay, at the beginning, we have some loan amount, which is L. Okay, let me get a different color. So now what we want is, we want to know at this point, right, what would be the remaining balance. So first of all, my original loan goes to this would be L times 1 plus I to the t, right? So this is the how I convert the original size of my loan from time 0 to time t. This is how much I have borrowed at time t. Okay, so of course L is what I borrowed at time 0. If I convert this time to t, this is what I would have borrowed. Minus what? Minus what? Minus the payments that have already been made. Right, from 0 to t, I made t payments. And now I need to accumulate them to time little t. So it's the accumulated value. So it's S, right? So that's why this method is called retrospective. I use the loan amount minus what has already been paid, right? In the prospective, I look into future. I want to know what would be the present value of the remaining payments. In the second method, I use the loan amount minus what has already been made. So those are the two methods we have down here. It's really up to you, which method you would like to use, right? Whatever works for you, it's fine. In here, of course, you will get the same result. 1.0622 minus 1186.90. So it's a future value, so it's 1.06. Now I have done 2 minus 1 divided by I, right? So you will get the same result. Okay. Actually, I made a little Excel. So let me zoom in. So whenever you try to get a mortgage, you will probably do some. That's much later on. Maybe your parents have mortgage, or some of your family members might have mortgage. Uh, when they apply for mortgage, they will look at. Of course, you will need to know how much you need to borrow, right? Might be 80% of the closing price, and then this is the interest. Here I assume this is about for our example. So it's the annual interest rate, which is 6%. For the mortgage, usually it's the piecely interest rate. It's the monthly interest is quoted. Okay, so that's the what we call the nominal interest rate convertible monthly. Okay, but here it's just the annual effective interest rate. I have 5 years, and this is the amount I actually calculate. Let's look at it. So it's B1 times B2. B1 is L times I divided by 1 minus 1 plus I to negative N, right? So that's the formula. I use this formula to calculate. So I typed in this 5,000, I typed in this 6%, I typed in this 5. I used those three numbers to calculate this payment, okay? Now here is what's really important. We have three important columns: balance, interest payment, and principal payment, okay? So basically, if you add those two, they will always be these payments. That's how I calculate the other one. Okay. So we start with 5,000 because 5,000 is the amount I borrowed. So that would be my balance at time 0. So according to what we just studied, the first thing you do is to calculate the interest, right? Interest equals the previous one times the interest rate. So the previous balance here is 5,000. According the position would be E2 and interest rate is B2. So as you can see here, the E2 means, so if I click on, you see E2, B2, right? E2 is here, B2 is here. A little different for B2 is I put a dollar sign for B, dollar sign for 2. In Excel, that means I want to fix that in my formula. I don't want that to change, okay? So this is a fixed entry. And once we hit return or hit enter, you will get the result, okay? So this is how I calculate interest. It's the previous balance times the interest rate. Then I will get the interest, the amount of interest I need to pay in this current year, okay? Since the payment is fixed, I know 300 will be paid towards interest, then the rest, the remaining will be paid towards principal, right? So this will be my X. So here is X, right? So again, it's fixed. I fixed this position minus a varying term. F3 will be varying because later on, you see here, it's minus F4, right? So that's how I drag to get the result. Okay, meaning, so let's then you will let me delete everything, then you will see what I meant. So first, this is how I calculate the first one, and then this is how I calculate the second one. This is simply the percentage. Okay, how much of the principal? What would be the percentage of payment that is made towards principal? Okay, and then all I need to do is just to drag. This one I still need to mention. We have this first. Okay, the first one we have is this 5,000, the previous balance, and then we get the interest, right, which is 300, and then we use X minus the interest to get the principal payment. Okay, that's the next. Once I have this and this, I can calculate the current remaining balance. That would be the previous one minus this, the payments towards principal, right? So that's why if you see this formula, that is E2 minus G3. E2 is the previous. G3 is the payment towards principal or towards balance. So this will be my remaining balance, right? Okay. In Excel, you just need to drag, then it will fill the answer. It hasn't calculated yet, right? So of course it will change, right? So this is the results. In the second year, I will use the first year balance times interest to times interest rate to calculate my new interest. You see the number is the same. And then I will use X minus 246 something to get this principal, right? And then this minus this will give me the current outstanding. So it goes on to 5 years. This is because we have a rounding, so it's not exactly showing zero. It should be zero, okay? In theory, it's just some rounding. So you can see here it goes to 10 to negative 12. So there are 12 zeros, so it's almost a zero. Okay, and then of course, if you want, you can also drag to see the percentage. Right, you can see here is increasing. The percentage of each payment made towards principal goes up. That is because we take care of interest each time. So the balance is going down. The value of balance is going down, right? Otherwise, you will never be able to pay off a loan. So whatever you pay will always be bigger than the interest. Okay, so interest is already paid off. So we paid off each interest. So, and because of that, the outstanding balance is being reduced through time. That's why the percentage made towards principal goes up, right? From 70 something all the way to 94, right? And then I do summation. I sum up all the interest payment. I sum up all the principal payment. Obviously, you know, this is not surprising to see that this number is 5,000 because that's exactly the number I borrowed. But there is a cost, right? It does not come in free. And you can see, in order to borrow this loan, 5,000, I actually paid more than $930, so nearly $35 in interest, right? In order to get this loan, you can. I will upload this Excel file so that you can play with. You can change it to anything you want. Let me save this and close. Then let's go back to our lecture. So basically that answers all the questions we have, right? We're also trying to study the total amount of interest that is paid on loan over, well, that is obviously total interest. Let's go back to our usual color. Total interest would be n times x minus L. Right? That's simple, right? X is the size of each payment, n is the number of payments. So times them together gives us what would be the raw total of the amount of money we have paid, right? And minus the loan amount, the difference would be the interest, okay? By the way, it's already computed in my Excel file. We can calculate anything, right, from those formulas. So first of all, we can either apply the prospective method or retrospective method to get the balance, right? The current balance. Okay. Once we know the balance, we can use balance times I to get the interest for the next period. Okay. And X minus the interest would be the amount of principal paid. Let's consider a slightly more complicated example. What is the more complicated? Let's go to a new example. Example 5.18. Okay. What do we have? We have L is 15,000. We are trying to use amortization method, but now it's monthly. So that doesn't really matter. So at the end of each month for 8 years, the nominal rate of interest is 8% convertible quarterly. Okay, we need to do some preparation. Okay, here things are a little different because, so first of all, let's use J to denote the monthly interest rate. So monthly effective interest rate J would be 1 plus I4 divided by 4, 1 over 4. Because what do you get here? So let's do it in one more step. Okay, let's don't jump. Let's do it in the standard way. So 1 plus I4 divided by 4 raised to the power of 4 would be 1 plus I. This is annual interest rate. Okay, now let's introduce I upper 12. Okay, and let J be I upper 12 divided by 12. So this is the monthly interest rate. Okay, of course we can easily compute this, right? So we get this is, well, okay, what do we have? We get this to be, we have I, but the question calculated I12. So it's 7,473. Obviously, we need to divide it by 12. Okay, use your calculator to get the result. So once we have that, then we need to know what would be the total. So let's use N to denote the total number of payments. I have 8 years. Okay, obviously in each year there are 12 months, so 96. So 96 payments. So now I want to know what would be the amount I need to pay in each month. This will be L divided by A, N, but now it's J. Okay, or you can write NAP if you want. I don't like the notation. Let's use NP because textbook use the piecely payable. I don't like that. It's not helpful, right? Because we have the standard formula. There's no need to go through that. Okay. Once you do the computation, you will see, well, it's about $200. Okay. This step by now, I really hope all of you can easily get X. Once we have X, the next question is the principal outstanding at the end of the 4th year. At the end of the 4th year, okay. At the end of 4th year, depends on what. So let's say year 4. 4 year. This is the 8th year. Okay. We want to know the outstanding balance. Okay. Well, first of all, you need to figure out the corresponding number to months. This would be 48 months, right? This obviously 96 months. So we have two methods, right? We have the prospective, which means we look into future, right? How many years left? So B 48 equals X times A. So we need to count how many left, right? Obviously, I still have another 4 years. Since I have another 4 years, there are going to be 48 payments given J. Right? J is the monthly interest rate. So I use the second timeline to work. So let's do it this way because I work with monthly. So I put monthly. So here's 48. Here's 96. So this is months. This is month. This is the 4th year. This is the 8th year. Okay. So for each, there are many X, right? So there are in total 48 payments remaining. So this is the prospective method. You can easily get the result. It's 8678.40. Okay. The reason why I prefer this over the textbook notation is because our calculator can easily get you this result, right? There's no need to go through the P3 payment notation. It's awkward. It's somehow even confusing, right? Let's stick to the very standard notation, okay? Of a equal annuity immediate. That we don't do P3, okay? If you want, you can do this if you want, okay? They are equivalent. Not 8. We have 4 left. So here's 4. Okay, they are the same, but I don't like it, and I actually don't recommend you doing that. But of course, you can also try retrospective, right? So if you try another method, this is the first method, this is the second method. This is the original amount I borrowed at time 0. Let's convert it to the 4th year. So again, this is the annual interest rate. Okay. Then I need to minus how many payments I have already made. In total, they are 96, right? There are 48 remaining. Of course, I made 48 as well, right? Check whether that gives you the same answer, okay? The interest and principal repaid in the 48th, in the 49th payment. So whenever you want to know the 40, so here is 49th, you go 1 period ahead because we need to know the previous balance, right? That's why we study 48. So now we have 49th would be the previous balance, capitalized I, times the monthly interest rate. So here's monthly interest rate, okay? Please make sure you get the correct interest rate for the unit you need. Okay, so here everything is in monthly, so I times by monthly interest rate. So this is about $57.47. Okay, once I know the interest payment, I easily get the principal, right? It's the equal payment minus the interest. So I get the principal, which is 154.18. Okay, and then that's the end of 5.18. Of course, you know this. There are many things you can do. 5.19, it's a little complicated because so this is something extra. Okay, if you are able to understand the standard 5.18, that's enough for passing this course. Okay, for a little extra, let's take a look at 5.19. So this is something similar. The amount is the same, and I want to pay it back in 10 years. Okay, now it's annual payments. But each payment is $100 more than the previous. So here is not level annuity, right? And I also know the interest rate is 4%. This is a little tough. That's because, well, I don't exactly know how to easily set that up. That's why let's draw a timeline. So 10. Let's say the first payment, I write it in this way. So my first payment is actually X plus 100. The reason why I'm doing this is because we know this is an increasing annuity, right? It goes up by 100. And what is the text? Okay, so let's follow textbook. Otherwise, we have two different X. So here I have X. Here I have x plus 100. Here I would have x plus 200. Goes all the way to, in the end, I will have x plus 900. So those are the 10 payments, right? So now, I hope by now all of you are comfortable of decomposing, right? There are two different ways you can do. One way you can do is do this. Decompose this as x minus 100 . Okay, then my original amount would be equal to level payments of this. This is level, so it's the annuity immediate. And then I have an increasing annuity for 10 years. Okay, and obviously I can solve this equation to get the result. Textbook does something slightly, I think it's the same, not even different, because there's another way of thinking this. This is one way. Okay, from there we can solve to get x. Let me write down x. $5,746.82. You can think this slightly different. 900, I can write it as 100 times 9, here's x, okay? So obviously the bottom one is very easy to handle, right? But for the top one, I have my first payment at time 2, my last payment at time 10, and obviously I have 9 payments, right? But once I do this, I go back to 1 period ahead of my first payment. So it's at time 1. This is time 0. So I will need to discount by a factor, right? 1 year factor to go back to time 0. So this is another way. This is alternative way. Let me put it in a bracket in case you want to know. Okay. So once we know this, we know the first payment, we know the last payment, and the principal outstanding at the end of 8th year. So I have 2 payments left, right? So that's not exactly complicated. So let's use prospective method. So I have 1 payment at time 9. So if I go up a little, right, then I would know how much I would owe at time 8 after the 8th payment, right? I owe this, I owe this. I just need to discount those 2 payments back to time 8. Then I would know the remaining balance at time 8. You can also try to use retrospective. That's slightly in this question. It's more complicated. Okay, this is the first method. How about the second? L is the original one. Okay, to time 8. This part is easy to handle. Okay, now I will need to calculate the future value or the accumulated value. Right, we can also do this. Right, what we can do is there are also 2 different ways you can try. X minus 100 plus 100 IS. Okay, plug it in to see whether you are able to get the same result. This is slightly more complicated than the prospective method. Interest and principal paid in the 5th payment. Okay, we want to know the 5th. So our first job is to calculate before, right? Before, again, there are 2 different ways to compute. If you look, so here's before. You can try retrospective. You can try prospective. Either way, it should be it should work out. What are the methods? So what you can do is to discount back. Okay. Well, in this case, there are very few So if there are very few, the easiest way is to simply discount everybody back, right? What you can do is x plus 400 times a discounting factor goes all the way to the last one discount back by 6 years. So this is prospective, right? This is the last payment, the second to the last, or this is the fifth payment, right? We discount it back. And then you can see here, okay, the reason I factor out x plus 300 is because I can easily see that the increment is still 100. So I keep the first 100, whatever the remaining will be my level payments. For 6 years, right? This is a level payment. So the level annuity. Okay. Actually, in this case, doing the retrospective might be, well, they are around the same level of difficulty. You can also try this. L times 1 plus I now is to the fourth minus the first one. You need to count how many years, right? So I need to go to year 4. Okay, the first payment is X. So the 1, 2, 3 years, right? So the 3 years. X plus 100. Then I accumulate by 2 years. X plus 200 accumulate by 3 years. And the last one does not need to accumulate. So this is the retrospective method, right? You should be able to get the same result. Once you know that, interest is fairly easy, right? Just need to times by the monthly interest rate. Once I know I5, I know P5. P5 would be, what would be my fifth payment? X plus 400. So, remember here, the payment is not the same, right? So it's not X, it's actually X plus 400. So that's something you need to keep in mind. I guess that's everything, right? So please try solving those on your own. That's the most important thing. And you can also play with my Excel if you want.